Hello and welcome to Pythian's Expert Insights, a series dedicated to providing expert knowledge on the bleeding edge of technology. Today, we are joined by one of Pythian's principal consultants and Microsoft MVP, Warner Chaves, to discuss how to build a high-performance SQL Server virtual machine on AWS and Azure.
Hello everybody and welcome to High Performance SQL Server VMs on AWS and Azure. My name is Warner Chaves. I'm a SQL Server MCM and Data Platform MVP with Pythian. Very short bio here before we jump into the material. I've been working with the Microsoft Data Platform for about 10 years now. I used to be a level 3 DBA for Hewlett-Packard in Costa Rica. Now I have the pleasure to be a principal consultant in Ottawa, Ontario, Canada for Pythian. There's my Twitter handle, our company site and blog. Make sure you pay us a visit at pythian.com, and my personal blog if you want to hear some of my other tech material at sqlturbo.com as well. And I'm a Microsoft MVP, so you can see from the badge over there as well. So the agenda for today, well, the main goal is that we're going to introduce the models of virtual machines and the different storage types that you can use to build high-performance SQL servers, both on Amazon Web Services and on Microsoft Azure. Now, I want to highlight that I'm going to focus on building high-performance SQL servers. I am not going to necessarily focus on building the cheapest virtual machine that can run SQL Server in the cloud, nor am I going to go into topics like high availability, which are obviously very important. They're just not the topic that we're going to focus on. So a little bit more detail of what we're going to look over today. I'm going to look into the virtual machine model choices on AWS and the storage choices on AWS. Then we're going to do the same thing, virtual machine model choices on Azure and the storage choices on Azure. And then we'll do a recap for both as a way of a summary before the end. So let's jump into Amazon Web Services. As we all know, Amazon Web Services was really the first big cloud provider for infrastructure as a service, and it's really now in the forefront of the public cloud providers. Microsoft has definitely made a lot of big jumps into catching up with Amazon, but the biggest one right now for sure is still Amazon, and it's interesting now. It's going to go into both services how they kind of compete and catch up with each other. So the main thing to consider for the Amazon choices for VMs for SQL Server is that there's a lot of different types of VMs, and they're all kind of optimized for different things. So I'm going to go through these types here. For example, we have general purpose T2, and that's it's not really built for high performance, but it's a special case. So I wanted to cover so that if if you're only going to see one video and you're looking at this video, then at least you get a general idea of some of the instances that you can run on Amazon that are a little bit different than what you can run on Azure. We have general purpose called M4, compute optimized C4, memory optimized R3, storage optimized I2. I will go into detail on these as we move further along. So like I said, the T2 instance in Amazon is a special case, and that's why I wanted to highlight it. It allows for what's called CPU burst. What this means is that depending on the model of the instance that you choose, it's going to have a base performance. Usually what it does is that if you are not using the CPU, it will start to accumulate credits. So periods of low activity will accumulate CPU credits. If the CPU is running to about 20%, then you won't accumulate credits. It will simply continue to run so. However, if you are running lower than 20%, then the CPU credits accumulate, and then you can burst over the 20%. And you can even burst over to 100% CPU for a certain amount of time as your credits allow. So for example, credits are spent, and 1 credit equals 1 minute of full CPU. As you can probably realize, this is not really to be used for a 24/7 workload because you will just run out of credits and won't be able to go over 20% CPU. However, if you have small workloads that run specifically on some specific times of the day and then the server is mostly idle, this is a good way to have a really good performance to cost ratio. Again, it's not really targeted for a high performance database workload in the cloud. However, I wanted to highlight it because it works very different from anything that is offered on Azure. In Azure, there is no concept of CPU burst, and this concept really just belongs on AWS. So like I said, if you're watching only this video and you're getting acquainted by all these concepts only with this video, I want you to have that concept of CPU bursting, that you can do it on Amazon, that it's only for smaller time-based workloads. It's not really for high performance, but for completeness of view, I wanted to include it in this video as well. Now let's talk about the ones that can't actually be for real 24/7 high performance for SQL Server. So we have compute, memory, or I/O optimized, and each type caters to a particular strength. So we have C4. C4 is what's known as compute optimized and has the most powerful CPUs that you can get on AWS. So this one is not going to have maybe the biggest amount of RAM or the fastest I/O, but it's going to have really, really powerful CPUs. So if maybe you have a database that's doing a lot of analytics, that's doing a lot of, for example, computations that are happening in the CPU, but mostly the data is already sitting in memory. So this is a good instance model that you could pick. Now R3 is my favorite for AWS, and it has the best cost per gigabyte of RAM. Now the vast majority of SQL servers that I see out in the field are not necessarily CPU bound. They are mostly IO bound, and having tons of RAM is obviously going to help with this. And as we all know here, if we're watching this as DBAs, SQL Server is a very memory hungry application. So the biggest amount of RAM that you can give to it, that's what you want to give to it. Usually an R3 machine will have about 4 times more RAM per core than a CPU optimized C4. Last, I want to mention the I/O optimized, the i2 machines. These have very large and fast scratch SSDs. Now, usually these will have the same amount of memory as a memory optimized machine, but on top of that, they have really big SSDs that are attached to the machine. Now, these SSDs are not permanent storage though. If the machine gets bounced or if the machine gets turned off, the storage, whatever's sitting on that SSD local storage, will disappear. So this is for a very particular use case where you would need a very big temporal storage. So for example, a lot of people say, well, you could use this for Hadoop or Cassandra because those are distributed systems, and so one node goes out, it's not a big deal. Usually they're going out all the time anyway. For a relational system though, and specifically for SQL Server, there are a couple of use cases for this scratch space anyway. For example, for TempDB, which we know can be a big space and I/O consumer on many systems. It depends on the workload, of course. And also for the new SQL 2014 feature of buffer pool extensions. Because buffer pool extensions, we can basically extend our buffer cache into storage, and we can use it to extend into this SSD, really fast SSD storage. And the buffer pool extension works the same way. If it goes down, it's not a not if it goes down, sorry. If it gets deleted when the machine gets restarted, then it's not a huge deal, right? It will just get recreated when SQL Server starts up again. So depending on your use case, you might think of, I need a compute optimized. I have a small database, but it churns a lot of CPU. You can go with compute optimized. If you're thinking for more, I just have a classic database. I want some SSD, a local scratch. I want a lot of RAM. That's the R3. Like I said, that's my favorite. If you have a particular use case where you're saying, well, I do have a very large TempDB because I do all these temporary computations before I sort into a database, or I have this very large buffer pool extension because I started with SQL 2014 and that's the way I've architected my system, then maybe you should look into the i2 IO optimized machines. Okay, so let's go over now over the storage choices for SQL Server on AWS. Now remember, you pick 2 different things, right? You pick an instance model, and that's going to be either the compute, the memory, the storage optimized, and then you pick the actual storage that goes under your virtual machine. And there's 3 different types of storage volumes that you can create in AWS. First one is general storage. It's also backed by SSD. So it has a baseline of 3 IOPS per gigabyte, and it can also accumulate credits if there's no activity. And this can allow it to burst to 3,000 IOPS for about 30 minutes. Now, if you do the math and it's 3 IOPS per gigabyte, obviously 1,000 gigabytes will already be at 3,000 IOPS. So volumes that are 1 terabyte or bigger don't burst. They just stay that way. Now, the bigger one of these general storage volumes is, the more quickly it will accumulate credits and the longer it will be able to go. So, it's recommended that you don't create really small of these volumes. You create bigger ones, or you forecast into the future, do some capacity planning to create a bigger one. Now, the second one is the Provision IOPS SSD. Now, this is the most expensive choice of storage you can have on AWS, but it guarantees the same level of performance at any time. So if you're getting a certain amount of latency at, let's say, 3 a.m. and you're able to push the same amount of IOPS at 3 a.m., you'll get the same amount of capacity at noon, regardless of how busy the system has been, right? These IOPS are provisioned and they're always reserved for you. So it's not like general storage SSD where you can, you burst and then you go back down. It's more for like, the workload can go up or down. Provision IOPS, if you're really 24/7 demanding workload and you need always the same response time, then this is pretty much your choice for a high-performance SQL server. And the baseline that you get is 30 IOPS per gigabyte. Now, finally, the last choice there is magnetic. The magnetic disks, you can provision a lot of capacity for them, but they don't come with any type of performance SLA. All it says on the Amazon documentation is that you'll get, hopefully, double digits latency, but it doesn't say anything beyond that. So we're talking you could get, 11 milliseconds, which is double digits, or you could get 88 milliseconds, which is still double digits, but it would be terrible. So anything that is high performance should definitely not go on magnetic. I'm mentioning it here because of completeness and to give you all the options, but it's not for high performance. This is useful for stuff like archiving, like really old legacy databases, or when you have a big archive file group and nobody ever queries it, and if they query it every now and then they know it's going to be slow anyway. Low priority databases, dev or test. And dev or test also, it's only for, let's say you're testing functionality. If you're going to be testing for performance, then you need a machine that's going to be equal or very similar at least to production. You're not going to want to test on magnetic for performance. Something else to keep in mind is the bandwidth limits on AWS. So different instances of AWS have different bandwidth limits, and this impacts your storage performance because the bandwidth can become a bottleneck. Even if you provision disks that can throw thousands and thousands of IOs, if you picked an instance model in AWS that does not handle that much bandwidth, then you're still going to be bottlenecked by the bandwidth first. So this is something that is overlooked a lot of the times because it's not front and center on the AWS console. So basically you go on the AWS console and you pick the model, then you pick the storage, but it doesn't really tell you much about the bandwidth at any point. You have to go into the documentation and go read about the bandwidth there. So a lot of people will go through the whole process and maybe they're not experienced on designing machines in AWS, and then they just don't think about the bandwidth, they forget about it, or they just went through the creation process without considering the bandwidth as part of their design. And this is a big mistake because it is a critical component and it is going to become a bottleneck if you don't think about it before you deploy it. Like I said, if you put tons of really fast storage under your VM, if the bandwidth limit is hit first, then that's going to be your bottleneck regardless of how much storage you put under the VM. I have a table here with the bandwidth limits on AWS. Like I said, you can find this in the storage documentation of AWS. I'm going to just zoom in here so that you can see what's going on. So for example, there we can see that, let's see, for example, the C4 machines, they can do from about 62 megabytes all the way to 500 megs, right? So a C4 compute optimized, the smallest one, which is C4 large, can do 4,000 IOPS and 62 megs, all the way to 8x large, which can do 32,000 IOPS and 500 megabytes per second. If we go down the list, we'll see the max that they go to is to half a gig, 500 megabytes per second. This is where it's important to do the proper design before you go to production. If it's a new application, you have to estimate it. If you're migrating, it's easier because if you're migrating, you can actually put a, let's say, a perfmon on top of your SQL server and just do like byte transfers per sec on each volume, and then you can aggregate that and see how much bandwidth you're consuming on-prem to your storage, and then you can move that into the cloud. So for example, if you thought that you were going to get away with a C4.2 extra large, and that's what you had planned and designed, but then you go and you put that perfmon on premises, and it turns out that you need 200 megs per second of max bandwidth instead of the 125 that is offered by the 2 extra large, then you don't have a choice really. If you pick the 2 extra large, you're going to be bottlenecked by the bandwidth. You're going to have to move one step up into the 4 extra large so that you're at 250 megabytes per second, and that's going to be enough for you to have the same amount of bandwidth that you're used to having on premises. So like I said, this is not a really obvious thing. The portal does not make it really obvious, but it is very important as part of your design. Some other tips on AWS, for example, like I said, larger general performance volumes will burst longer, take less to refill the credits. So if you're, for example, you're creating a volume for a database and you're thinking, well, it's only 150 gigabytes right now, but you're estimating that it's going to grow to 300 gigabytes by the end of the year, then you'll get better performance if you just create it right away as a 300 gigabyte volume. There's other machines that are optimized for really fast storage, really fast network as well here on AWS, and they can apply to SQL Server if you need them. So the C4 8x large or the D2 8x large, D2 is called a dense storage instance. These offer dedicated EBS bandwidth, and on top of that dedicated EBS bandwidth, which is the bandwidth table that we just saw, they also have a 10 gig interface just for network traffic. Okay. And another tip, if you are working off of a VM that you create a backup and then you snapshot restored it, you want to pre-warm that snapshot restored volume. Otherwise, you pay a first access penalty. So what that means is that Amazon keeps those snapshots on really cold storage, and then the first time you read from it, it moves from that cold storage into the EBS storage of the virtual machine, and then you pay that penalty. If you can pre-warm the snapshot, what that means is that basically your VM is going to read everything so that it all gets moved into the VM EBS storage. And on the Amazon documentation, there's steps on how to do this for Windows. There's a utility called DD that'll basically, you point it to a volume and it'll just read the whole thing, and that will make it enough so that you have pre-warmed the volume, and then you won't pay that first access penalty. All right, so now let's move into Microsoft Azure. Like I said, Microsoft is now, at this point, the contender, is the one that is trying to hit above its weight to go into Amazon's market. And there's some really interesting stuff that they've been doing as well in the infrastructure as a service space to try to catch up. And I really think at this point, if you want to build a really high performance SQL Server, now you can do it in Azure as well. As I'll go through the slides, you'll see why I say that. So VM choices, let's go into virtual machine choices if you're going to build SQL Server on Azure. So the A series was the first generation of machines that was available on infrastructure as a service on Azure. Now it has been surpassed by 3 different series of machines, the D, the G, and what's called as the DV2 series. All these machines have improved specs. They have faster CPUs. Some of them have bigger amounts of RAM. The DV2 series is very similar to the D series. The reason why it's version 2 is because it has faster CPUs than the D series. Now, the DS and GS series, they're basically the same specs as D or G, but they provide premium storage. Now, premium storage was not available at the beginning when Azure started to do infrastructure services. All we had at the beginning was blob storage. And to be really honest, blob storage was not good for high-performance SQL servers. So up until maybe, what was it, like 8 or 10 months ago where premium storage debuted, I would be really hesitant to recommend Azure for a high-performance SQL server. But now I don't have those reservations anymore. So that's what I mean by when I said just the slide previous that Microsoft has really become a contender for high performance workloads in the cloud is because of premium storage. Bandwidth limits, just like we discussed bandwidth limits for AWS, can become a bottleneck, but these bandwidth limits are only published for DS and GS series machines. Okay, and there's no bursting capabilities either for DS or GS. So none of this bursting exists, like the T2 machine that I mentioned on Amazon. They don't exist on Azure. Just simply whatever bandwidth you get or CPU you get, that's it. You're not going to be able to burst. So there's no similar to T2, like I said. So as opposed to Amazon, which has all these like memory optimized, CPU optimized, I/O optimized, the story on Azure is a lot simpler. There's either DS or GS, and that can be a good thing, that can be a bad thing, I guess, if you like a lot of choice. To me, it's a good thing because it makes the design decision a lot simpler. If you're going to create a high-performance SQL server on on Azure, you basically have two choices. It's either a DS or a GS. Now, DS was the first with premium storage. Now GS supports premium storage as well. GS has faster CPUs and more RAM per core, and obviously you get charged higher for that. However, if you have a really demanding workload that you want to put in the cloud, then it might be necessary and it might be worth it. So it becomes a decision of how demanding your workload is, and if you can stay with the DS or if you really have to go to the GS. So my specific recommendation is don't look into the A machines, don't look into D or G or DV2 for now. Go straight into DS or GS if you're building a high-performance SQL server. Check the specs, see if you can create it on DS. If you can't, then you're going to have to move up to GS. GS, like I said, they're just faster, more memory, and they have higher bandwidth limits as well, as we're going to see later on the slides. Let's talk about the storage choices for SQL Server on Azure. There's three types of storage. The first one is the Azure Page Blob Storage. This was the initial classic storage that infrastructure on Azure debuted with, and each volume is 500 IOPS and about 60 megs per second. This was not the easiest thing to work with for high-performance SQL servers. It required a lot of volume striping, and even then, sometimes you got really high latency. So again, I have some reservations about really high-performance SQL servers to be put on Azure Page Blob Storage. Thank God now we have the premium storage, which takes those reservations away, and I can say, yeah, we can build a high-performance SQL server on Azure. There's also the temporary scratched local SSD, similar to the ones that I mentioned that you can find in the Amazon machines, and you can put TempDB or the buffer pool extension on those as well. Now let's go into detail on the Azure Premium Storage. That's available in three different models, and I'm going to go into detail on what you get for each one. So it's called P10, P20, or the P30 volume. As you can see, the sizes there, P10 will get you 128 gigs of the SSD, P20 will get you half a terabyte, P30 will get you a terabyte. All of these also come with a read cache attached to the machine, so you'll get really good performance reading off of this cache that's attached to the machine. 500 IOPS for a P10 all the way to 5,000 for a P30. The bandwidth on each volume goes 100 megs from P10 all the way to 200 megs on a P30. And obviously you can attach, as we'll see, that this is the bandwidth limit per volume, but you can attach multiple of these volumes into one VM if you need more aggregate bandwidth, as long as your VM model supports it. Just like I discussed on Amazon, the bandwidth here becomes a design decision and a design factor as well. Now the monthly price also, this is interesting because in Azure, on blob storage, you don't pay for the amount that you allocate, you only pay for the amount that you consume, but on premium storage, the volumes have fixed sizes, and you're going to pay for that regardless if you're using it or not. So what I mean by that is, for example, if you have a P10 128 gigs, you're going to pay more or less 71 US dollars a month to have that P10. But you're going to pay that same amount regardless if you fill up that P10 all the way to 127 gigs or if you're only using 10 gigs of them, right? So good and bad. The good, it makes your bill very predictable. You'll know exactly how much you're paying for storage every single month. The bad is that you might be paying for capacity that you're not consuming. And the price goes up all the way to the P30 volumes, which is 135 US dollars a month. Now, if you aggregate all this, you have to really see if this is worth it. You have to think not only of how much your SAN cost, or if you paid it already, but think about if you're gonna, when's the next time you're gonna buy a new SAN. Think about the cost of maintaining that. Think about the cost of support. Think about the cost of your storage admins, and then you can see, is this competitive or not? Like I said, we also have bandwidth limits, similar to AWS. Different machine models have different bandwidth limits. As we can see here, for example, DS machines go all the way from DS1 to DS14. The biggest DS that you can build is 50,000 IOPS with half a terabyte of bandwidth. And this is pretty much the highest, the half a terabyte is on the high end of AWS as well. Now, GS is really where you can build machines that I would say it would be very costly even to build them on premises, and they're like for the most demanding high performance workloads that you can throw. For example, a GS5 is probably the fastest with biggest machine spec in the public cloud nowadays. Like you can go right now to the portal and create this GS5 machine that can do 80,000 IOPS, and you can do 2 gigabytes per sec of storage bandwidth. That is the biggest one you can create on the public cloud right now. And there are some workloads probably on premises that are too demanding even for that, true, but for the vast majority of workloads out there being run on premises, there is very little that you can't fit right now, either on AWS or definitely on Azure, even with these really high spec GS machines. Other tips on Azure. So the published best practices from Microsoft for data disks is to disable caching for page blob disks and have read-only caching for the premium storage disks. Like I said, this read-only cache for the premium storage disk is extremely fast. I've gotten some really good results with it. And like I said, from now on, all my SQL servers that I recommend building in the cloud, if it's on Azure, they're all going on premium storage. That's the way to go. If you're going to be striping, set the stripe size 64 KB for OLTP, 256 for data warehousing. Set the column count equal to the number of underlying volumes that you're mounting. You can do striping really easy with Windows storage spaces. Comes up in 2012 plus. Hopefully, if you're deploying something right now, it's on 2012 plus. Like I said, you can do this really easily with storage spaces. If you are working with page blob, then most likely you are going to need to stripe. It's not going to be a requirement just because page blob disks have such low baseline performance. And then the SQL best practices still apply the same. This is true for AWS as well. You have to be setting up your max degree of parallelism correctly. Make sure that you have the proper sizing of TempDB. All your files are set up correctly. You distribute the workload in different volumes, etc. Okay. All right, so a recap for what we learned for AWS. So the T2 instances, they have a good price-performance balance, but not really for high-performance critical workloads. They're for workloads that are mostly quiet and then they burst. I wanted to include them for completeness of vision so that you are aware of these type of CPU bursting instances. My recommendation in general is that you would pick between a compute, a memory, or an storage optimized instance. Which one is the best one for you? It really depends on your workload. For the vast majority of general workloads, I recommend a memory optimized instance because it comes with a larger amount of RAM. They're EBS optimized, and they also come with some scratch SSD space. Like I said, make sure it's an EBS optimized machine. That means it's a machine that has been optimized by Amazon for optimal I/O to the elastic blob storage. If it's truly high performance, provision IOPS SSD is the best option because it will not fluctuate during the day or depending on your activity. You will always get the baseline performance out of your storage. Make sure that you take bandwidth into consideration when designing your VM, and if you're doing a migration from on-premises, make sure you measure that bandwidth requirement before you go ahead and create your production VM on AWS and use the local SSD for TempDB or for the buffer pool extensions if you're running SQL 2014 plus. Recap for Azure. So the A series was the first generation. It has been surpassed by the DV2, and the G series. However, for a specific high-performance SQL Server, we want to go with DS or GS because these are the ones that allow premium storage. And premium storage is critical for having a high-performance SQL Server on Azure. Okay. For premium storage as well, make sure your VM has enough bandwidth. We want to make sure that bandwidth is not going to become a bottleneck. And there are published amounts of, like I said, the IOPS and the megabytes per sec that you get both for DS or GS. Make sure you take that into consideration. If you're using blob storage, most likely you'll need striping. I would recommend that you start planning to migrate from blob storage into premium storage. And the same thing, use the local SSD for TempDB or BP. If you take all these into account, you should be able to map your on-premises performance to virtual machines, both on AWS or Azure. The state of affairs right now is that you can build machines that are very, very powerful in the public cloud, such that the vast majority of on-premises workloads can be mapped to high-performance, reliable SQL servers in any of the clouds. And that's it for the webinar for today. Thanks for watching.
Thank you for joining us today to watch one of our expert insights. Remember, you can connect with Warner using the information provided here, and if you want to discover more about our expertise in SQL Server, visit the URL included at the bottom of this page, or simply email us at info@pythian.com. Thanks for listening.